Hello and welcome to another grade 10 math session where we're going to talk about some basic equations, getting into the algebra finally. We're using IXL as a convenient platform to just generate some examples for us. Feel free to explore that further or go to your favorite website platform to get some practice questions. We're going to do some linear equations. Now, linear is just, for now, code for the easiest kind of equation. Now, before we worry about this specific question, I want to just be aware of what an equation is. If I say that two sides, a left side is equal to a right side, usually they represent some sort of calculation, some combination of things, but equal means that they are perfectly in balance. So if you think about the old school balance scales where you had little bowls on either side and you could put stuff in here and you can put other things over there, and that was a way for them to measure the weight of different things. But the equal sign means everything is in balance. So for example, if I have, let's say over here, C plus 13, I have a missing number, C. I don't know how much that is. So if I think about it in terms of a balance scale, there is some missing C blob object. And I have 13 other standard weights. And on the other side of the scale, I have 19 and a half of the standard weights. And they're perfectly in balance. I can remove 13 standard weights, little units on the left, but then it's going to tip. So as long as I remove 13 on the other side as well, then logically the scale is going to still remain balanced. So that's what we're going to do in our equation. And the equation is really just keeping track of what we're doing on this balance scale. So what do we have left? We'll have this weight C left on the left, and we have 6.5 left on the right. And therefore, that has to be the weight of this blob C on the left. Let's put that in. 6.5. Submit. Now, when it comes to equations, we can be a little bit more sophisticated than acting out a balance scale. We can add by the same amount or subtract by the same amount on both sides. And you can reason why that would work through a balance scale. But perhaps a little less intuitive, but also still valid, is you can multiply. As long as you multiply by the same amount on both sides, this will still be in balance. Whatever amount I have on the left and whatever amount I have on the right, if I double them both, the scale will still be balanced, assuming I have room for that much multiplication. If I can split them in two, for example, division, as long as I do it on the same, as long as I do the same thing on both sides of the equation, the scales will remain balanced. So this is how I can manipulate equations without necessarily thinking of the practical balance scale. I'm erasing here. Get rid of this too. Erase, erase, erase. The equation is in the mathematical language just describing what happens to the balance scale, but in a more convenient, efficient way. So if I have r over 3 equal to 4, remember this is just r divided by 3. I now have to think, well, this is the calculation on the left versus the right. My goal is to do one of these 4 and maybe multiple times. I can choose only these 4 things to the point where I have this missing blob r, this variable alone on one side of the equation, and then the number on the other side has to be the answer, has to be the value. Same as before with my c. So now I'm going to say, okay, well, I need to counter this this division by 3. What cancels division? Multiplication. But I have to do it on both sides. So dividing by 3 and multiplying by 3, you can think of it as fractions. The 3 and the 3 cancel, or however you want to think about it, lots of ways. Leaves just the r on the left and a 12 on the right, and we have an equivalent balanced situation, but now we can read the answer for this missing quantity r, and it's 12. Brilliant. So the equations and the language of math through these equations give us a more efficient, convenient way to analyze this balance situation. Same thing here, q over 2 equals 2. Now I know what's coming. I have to multiply by 2, but I have to do it on both sides. I give myself some space there to fill in the multiplication and how I'm modifying this equation. But everything is still in balance, and q is simply 4. Let's see if we can get a multiplication or subtraction one. Subtraction or addition one. I like that. Okay, good. N is my missing quantity. This calculation said, oh, I subtract 2 from it, and that gives me a result. This is in balance. Now I have to counter that minus 2. I'm going to add 2 on both sides. For some reason, we just put it at the bottom here, but if I have enough space, I'll squeeze it in there. Now this is my calculation on the left, and minus 2 plus 2 cancels perfectly. 1.1 plus 2, 3.2. And I've rewritten my equation to a point where it's so simple I can read off the answer as 3.2. 3.1. I just made a typo there, sorry. But the nice thing about this website is it tells you. I just made a little typo. It's not 3.2. Get rid of that. Actually erase it. I can make mistakes too. Clearly, it's 3.1. I was just testing the website. That's all it was. So let's go actually, and I need to go to the other topic to see. Go back. Oh, I want to scroll down and clear this. There we go. And see, where am I now? Two-step equations. Because sometimes it's not going to be just one thing to do, but a couple of things. And the issue is I can add or subtract both sides, multiply, divide. So I have 4 options at all times. Which one do I choose and when? My goal is, let's just write this out. I'm going to leave some space there. My goal is to get k alone on the left, because then I can just read off the answer. And there's no guessing, no complications. But I might have to do this in stages. Now, thinking of BEDMAS, multiplication is happening first here between the 2 and the missing number, and then I'm adding a 3. It doesn't matter which way it's written. So I need to whittle this down by canceling this plus 3 situation first. Notice there is a plus there, right? 3 is being added. It's a positive 3. So I'm gonna actually write this in red. Not pink. Actually, pink. Pink is not as scary. I'm going to subtract 3, but I have to do it on both sides. Then, what do I get? I get just 2k, because plus 3 minus 3, cancelled. And I get a 4 on the right remaining, assuming my arithmetic holds up. Now, this is multiplication. So how do I cancel the multiplication? I'm going to put that maybe in blue. Blue. We're going to divide and write, not 3. Wow, I am on fire today. I multiply by 2, I want to divide by 2, but I have to do the same thing on both sides. We write it as a fraction, but of course fraction and division very closely connected, right? And that leaves just the k, common factors in the above and below the fraction line cancel, and I have a 2. Let's feel good about ourselves. Hopefully, yay, that is correct. Just do one more. Start with the equation. That's supposed to be a 1. I don't know what that is. 1 equals 2k minus 5. Now try and always do the same thing. Try and get into good habits. Repeat the same process in the same steps. And you know, personally, I don't like it when my variable is on the right side of the equation. It feels like different things are happening. But no, if one side is equal to the other side, I can flip the whole thing over. Just leave some space there for myself, like so. So flip it as you feel comfortable. And I'm just used to, it's more common to have variables on the left. So if the presented equation has the variable on the right, I just flip the whole thing. Play to my strength. I want that consistency, that repetition. So now let's go pink. We need to first think of sort of reverse BEDMAS. Multiplication happens first, then subtraction. Well, I have to whittle away from the outside in. So I have to get rid of the subtraction first by adding 5 on both sides. Then I'm left with 2 times k equal to 6. Let's go blue. This 2k is multiplication, so I'm going to divide both sides by 2 so that common factors cancel, or the multiplication is canceled by the division. And I just have k on the left and a 3 on the right. And if I think about it in stages, whittling down, not in one go, slowly doing one of 4 things to the equation. Yes, later it gets more complicated, not much. One of 4 things. It's just a matter of choosing which one do I do and when until I get k all alone on one side. K is 3. Let's submit it. Great. Now I'm going to leave this one for you, since this was just our little introduction. Let me know in the comments what you think the answer to this question is, and any other thoughts you might have, and we will chat again soon.
Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.